access information is called structured query language. Why do we need databases? Is because it's an efficient way of storing information. There is like so much digital information that we need to store. If you just store it in random files, it's hard to access them, or it's hard to search in them, or apply conditions on them. That's why we store it in a database. And whenever you store it in a database, the way you access that data is through a language called structured query language, which is what SQL is. So why you guys should learn SQL or why it's relevant? Jishnu will tell you more about it, but if you want a brief, then so this is one of the examples. It's called Slow and Digital Sky Survey. So this has like terabytes or even more data of the entire sky, but you can't obviously download the whole thing, or you may not be interested in the entire data. You're only interested in specific area of the sky or something like that. How would you communicate that to the database? That is why you need SQL. So this website allows you to search for data using SQL. Like this is an example data. So when you run this, you'll get some results uh, of the sky. So this is, if you see, this is SQL. We'll get into the syntax of it today. Very basic syntax, not deep into it. Some basic understanding of SQL. So some keywords in SQL. So the first thing is table. So everything is stored as a table. Anything, yeah.
Actually, my
Sorry,
was at my end, I can't see a screen.
you can't see my screen.
Okay, now it's visible. Yeah.
Sitara, is it for everyone or just? Can you see
No,
me?
no, we can see, we can see.
You can see the screen.
Okay. Yeah. So the way data is stored is in the form of tables. Table is nothing but rows and columns. So columns are names of the fields, and rows are like number of records. For example, this is a planet data, exoplanet data, where each of them has a Kepler ID, Kepler object of interest name, Kepler name, status, period, radius. So these are the um, parameters of the data, and each row is one of the records. So this is internally stored. You don't see this when it's stored. Like this is how it is stored inside the database. So if you want to see the data, you can run some queries. For example, if you want all the rows from the table planet, you can say select star from planet, and if you run it, you get all the rows of from the table planet. Uh, so each entity is stored in different table. For example, there is a table called star, and this has only Kepler ID, effective temperature, and radius. So if you want all records from star, you do select star from star. Uh, if you want all records from planet, you do select star from planet. Um, yeah, but you can't do select star from on this database because it will be huge. These are like all rows. It will be in maybe even more than terabyte. So you'll have to apply certain conditions. Um, for example, let's say we want only the stars whose effective temperature is greater than 5000. So you can say where P of F, which is the column name, is greater than 5000. So if you run this, um, okay, let's say 6000 instead. Is it running? Uh, Hold on. Give me 2 minutes. Sitara, you can talk to them for 2 minutes.
What should I talk to them?
You can tell them about.
Okay, has anybody used SQL before?
Uh, I learned about SQL in my 12th grade.
Oh, really? Okay, okay. But was there like a use case, or did they just kind of teach it as an additional thing?
No, we just kind of learning all the syntax and like how to access the database and stuff.
Nice. Okay. Has anybody accessed data from SDSS or some other source as well using SQL perhaps? Anybody from this group? Nobody. Okay. Cool. Yeah. So I think the advantage of this is if you don't have like a file of ready-made data. I think some of you worked on it, but usually it will be given to you, right, in smaller projects and so on. But if you want to do something on your own, then you're looking for a very specific kind of data. Let's say Cepheid variables, but you want it from a specific galaxy or cluster, right? So how do you know or how do you access it given that you have certain conditions or constraints? So that's where SQL really comes into play. It can also it's also very much used in exoplanetary research. So those of you who want to access data about exoplanets, it's actually pretty simple to do using this. So once you get familiar with the basics of SQL, after that, if you go to SDSS, you get a lot of information. Um, yeah. Okay.
Okay, that website has some trouble.
This is
Doesn't
only better,
work.
Jivan. You can continue with this. You can maybe zoom in a little bit. It looks much better here. It's okay. Yeah.
So yeah, like I was saying, if you do select star from star, that's table name. You get all the rows and all the columns here. This is the output. But let's say you want certain specific columns, then you can mention the column name. Now, if you run this, you get only this column name. If you want more column name, uh, column. So this way you can access only specific columns from the table. But if you want all the rows, all the columns, but only specific rows, that you can apply certain conditions. As I was saying, you can select stars whose effective temperature is greater than maybe let's say 6,000. Now you'll get only limited set of data. That's only 5 rows. You can also combine certain conditions. You can say greater than effective temperature is also greater than 6,000 and radius is also greater than 1. So you can do this. So now you can see you only have 3 rows. So this is the way you communicate with the database to access only certain information that you are interested in instead of fetching all the rows. Here the total number of rows is very low, so you won't know the difference. But if it's like huge, then you are interested in only certain set of data. Here again, instead of star, you can select only certain columns. Let's say only Kepler ID or T effective. So is this language intuitive? It looks like English itself. It would. This is how you would say it in English. So hope it's intuitive enough for you. Mm, what else can we do? Let's say you want only the top 10 records. Then you can do select star from star limit 10. Okay, one, two, three, four, five, six. I think there were only 9 rows in the first place. Let's say five. Then you'll only get the top 5 rows. Let's say you want to order them by effective temperature, like you want to sort them, then you can say order by P effective. So this is ordered by effective temperature. If you see, it's in ascending order of effective temperature. If you want in descending order, mm, you can say DESC. So this will be now arranged in descending order. Yeah. Mm. Any doubts so far? Or it's not making any sense?
I think it will be a little bit more helpful if you describe the this thing also a little bit. The column names.
Okay. I think you can do that. You want to explain the column names?
No, so yeah, we have Kepler ID. So basically, there are two tables, right? I think that's clear. There is stars and then there is planets. So what you're trying to do is initially you're trying to get familiar with how to access data from individual tables like stars or planets. And this code that he's kind of displaying right now is for creating the table itself. But often you're going to probably have a table sometimes. So then you just want to extract data from it. And then each table has different column names like radius of the star, effective temperature. But always there will be one column name which is unique to that table. So I'm guessing here Kepler ID for the star is a unique, parameter. For example, if two stars end up having the same radius, same type of star, same effective temperature, then how do I tell the difference between them? So that is where this unique key comes in. And similarly, probably coin name or something like that is a unique parameter in the planets table. So these unique parameters will be very useful when you want to somehow extract data from both the tables, right? You want to say, give me the planets that belong to this star, right? So when you want to somehow join these two tables or access data from both of them, then these unique parameters become very, very important. They have a technical name. What is it?
Uh, Primary key.
Yeah, it's primary key. Correct.
Yeah. So here, KOI name is the primary key, not really Kepler ID, because multiple stars can have the same Kepler ID. Uh, then they belong to the same. Like multiple planets can have the same Kepler ID. They belong to the same planetary system. Is what I read. So here is a query to select confirmed exoplanets. This is the database of exoplanets, and it has a bunch of status. Some of them are confirmed, some of them are false positive, some of them are candidate. So this will be stored somewhere in the database. How do you get only the uh, exoplanets which are confirmed? So you can do select star from planet where status equal to confirmed. Do I do something?
Maybe the name is wrong. Go to the
No,
code.
some data is messed up. Yeah. So if you see here, all the status is confirmed. But if you remove this condition, you will get a list of all planets, which it can be any. Some of them don't have a Kepler name, which means they're not confirmed planets, exoplanets. If you want only the confirmed planets, one way to do it is check status is confirmed. Other way to do is check if Kepler name is not null, which is not empty. So you can also do Kepler name is not null. So even then you will get the same result. So this is just list of all exoplanets which are confirmed.
May I ask something?
Sure.
So basically, we'll just extract the information, right?
Correct.
Then why do we need to learn like a programming language? Can't we just use like something like Google Sheets and press the find button?
Something like what? Find
Something
button.
like Google Sheets, yeah, and then using the find button.
Something like spreadsheet and find button. Okay. Let me, so first of all, spreadsheets. I don't know if it can handle terabytes of data. Uh, Also, you can't combine multiple spreadsheets, right? For example, there is one spreadsheet for planets, and one spreadsheet is stars. How do you run queries in both spreadsheets? Certain information from this, certain from that. You will need to combine them. That is one reason. Other reason could be storing it in text format is not really efficient. Um, so that is why databases are. So these queries run much more faster than what you could run in a spreadsheet. That could be one reason. But basically, they are stored in a similar format. Both are tabular format only. Spreadsheet is also tabular. Here also it is tabular format. So it's just that it's more flexible, faster. It can store much more information. It can spread across multiple computers, and it will still run. So even if certain data is in computer one, certain data is in computer two, if you run the query, it will still combine the data and give it back. So it's a good question, but this is just advanced spreadsheet, you can say.
So may I ask one thing?
Sure.
So in this in SQL we create our own tables and store our data. Then we will go through that performance, what task we are going to perform, like
Okay.
to select column or rows or anything which
Correct.
we increasing decreasing order anything.
Correct.
So why don't we use the means Python in like we same can use that means in like pandas or numpy, like we can use the data and the description and what like all we can do the same thing if we have the CSV file, the data sheet.
Got it.
And in SQL we are creating those tables and then we access that.
Yeah. So database is more about storage than about
And like
query.
if we use like Kaggle or Google Colabs, it won't use your system storage. It's directly online, and you can use their server and then perform your means experiments which you can go on programs or like that. So we use SQL over like that.
Yeah.
But
So what?
what if you don't already have the data set? You're saying you can use pandas, right? But pandas you can use after you have the proper data set or the CSV file.
Yeah, ma'am. Like in Kaggle, like so you have the means you have data sets there in CSV formats, so you can use put
Correct.
and use them. Yeah, put them and then go on.
Yeah, that
Yeah.
makes sense. But when you have something like the Sloan Digital Sky survey, how do you go to that uh, website or an online source of astronomical data and then query the data? So you cannot access information from there using pandas or whatever, right? So first, even to access the CSV files or the database, you need to know SQL to query it
Yeah,
from the source directly.
that is one reason. If you want a more technical reason, uh, when you are dealing with files and a programming language like Python, to read information in the file, you need to load the file into the memory, correct? Only then you can read the file. And your memory is usually memory, by memory I mean RAM, okay? And your RAM is usually 4 GB, 16 GB. So that is the most you can load into a memory at a certain point. But databases are stored in hard disk, not in memory. So the queries are run on the data stored in hard disk, and hard disk can be huge. It can be TB or anything like more than that. So that is the reason why we use database. It's more of efficient way of storing data. Like RAM is limited. You can't load everything into the memory. Uh, and as soon as
Yeah,
you
got
store,
it, sir.
okay, and as soon as you store the data in database, SQL is the only way you can talk to it.
Yes, sir.
Cool. Of course, you can use Python as well, but you would still have to write queries itself within Python. So Python can also interact with the database. But so why CSV versus database is that's the reason. Okay. Mhm. We can also run certain statistics on the files. We can get the minimum radius of planets. So you can say min and the column name from planet. If you run, you will get, you can see that 0.49 is the least radius in this whole thing, this whole data. If you do max, you'll get the max. You can do average, and a standard deviation is also there. This you can run on any column. So this will instantly run, even though the data is like huge, this will instantly run and give the result back to you. It's very fast. Mhm. Let's see if we can omniplanet multi-planet system. Yeah. So as we saw in the data, Kepler IDs were not unique, but KOI name was unique. So now we can find all the planets in the planet database that are in a multi-planet system, which means um, any Kepler ID that has more than one planet is in a multi-planet system. So how will you write that? Let's say, you can say, let's get all the Kepler IDs and we can count the Kepler names Koi name, because they are unique from planet. We need to group by Kepler ID because Kepler ID is not unique, and having count of Koi name greater than 1, let's say. Yeah, so these are all the planetary systems which have more than one planets. If you want,
Excuse me. Yeah.
yes,
Hello. Yeah.
yes,
What is that last sentence says? Coin name.
that is Kepler object of interest name. That is a name given to each object of interest. Um, so it is not at an exoplanet, but it's observed. So you give a unique name to it. That is called Koi name. KOI means Kepler object of interest. Siddharth, do you have more insight on this?
Okay. Thank you.
Yeah. So this is always unique for every object. It is unique. Only after it becomes an exoplanet, I think it gets a name called Kepler name. So this is Kepler name. It gets Kepler 1, Kepler 2, Kepler 8. But before that, it's called something else. Some random name it's given. So if it is not a exoplanet, it's not given any Kepler name.
Yeah, now it's clear.
Cool. Yeah, so here we grouped by Kepler ID, uh, and we counted how many KOI names are there for each Kepler ID, which will give us the planetary systems, multiplanetary system. Let's see. Let's see how to combine two tables. So we have now planets and stars. So some of these planets are part of this star system. So how do we see that? So both of them have something called Kepler ID. Um, so you want um, like you want to get which planets belong to which star system. So you can do select, or let's say we'll get what do you want to get? Okay, select star from star. So here we combine data from star and planet. So we kept Kepler ID and constant, and we combined the uh, two tables here.
That's the shared key, right? So there'll be one key which is common to both the tables. That's the only time you can use this, basically. So
Yeah.
Kepler ID is something that planets can share similar Kepler IDs. Are you sure Kepler ID is not unique for star? I think it is. I think Kepler ID is a
It's
unique
unique for
plan.
star, I think, but
Yeah,
not.
yeah, it's not unique for planets. So basically, let's say we are talking about the solar system, our solar system. So our sun will have a particular Kepler ID, and that same parameter will also be there in the planet table.
All
So Mercury,
the
Venus,
planets
Earth, Mars,
belonging to that star
Sun.
system will have the same Kepler ID, I think.
Yeah, exactly.
Yeah.
So you always need to have a shared or a mutual key in order to be able to join tables using this very simple format.
Yeah. So we can even check if that is true. So let's count how many stars are there, how many record stars are. Constant. So it gives a count as 66. You can also select distinct from that. I've forgotten how to do distinct, but yeah, there's one more way to do. Select star from star group by Kepler ID. It has 66 rows again. So yeah, um, when you group by Kepler ID, also you have 66 rows, and when you just do a count, you have 66 rows. So you know that it's unique for each star system, each star. Yeah. So let's try to get uh, planets belonging to a star system. So Tara, can you tell me the query? The test.
Mm,
All the planets belonging to a
particular solar system, right?
correct.
Yeah, so select all from planets where,
Okay.
no, it will have to be grouped by, right?
Mhm.
Wasn't there a code already?
No, you're not supposed to see it.
Okay. Yeah, anybody from participants can also contribute, guys. We're all learning this together.
Um,
So basically,
It
the
is planets from planets. Select star from planets, not planet. There's an S there.
no, that's a file name. It's a table name is planet.
hey, it's not case sensitive, is it?
No, it's not cases.
Right. So
Just,
So can you repeat once what you're trying to do?
I'm
yeah,
getting
yeah,
all the planets. So I want to group by Kepler IDs and get the number of planets, right?
correct. Which means we have to group by
Can't
Kepler
you
ID.
do a for loop?
No. This is slightly
No.
different.
I'll repeat the question again, guys. Let's try to solve it together. So the point is, we are trying to categorize all the planets according to which solar system they belong to, right? So Kepler ID is the unique thing for the star system. So, for example, if Sun has a unique Kepler name, it should say Sun and then a list of all the planets that belong to Sun, right? So we're trying to group by the Sun. Um, yeah.
If you group by sun means a Kepler ID.
Yes, you should group by Kepler ID because Kepler ID is common.
Yeah, and we have to select the planet where means the planet whole column from where we are going to select.
Correct. Yeah, I think I got it.
I don't think it's very tough. Yeah, it's just group by Kepler ID. Correct.
So these
What
are
is the right side? Count, is it? Oh, we
so
don't need. Okay.
we will do planet. I guess. Yeah. So this will give for
You
each.
should do planet.coin name. Can you go to planet.coin? Count planet.coin name.
It's the same thing. So basically, how many matching Kepler IDs are there for each star Kepler ID, and count it. For example, 217304 is Kepler ID of a star. How many matching planets are there for that Kepler ID? And you count them. So this is the query for that. You can ask any doubt.
But you have to query the primary key of the planet table, right? So planet.coiname, count planet.coiname. How does it know what to count then?
It counts the number of planets that match this Kepler ID.
Okay, yeah, I guess that should work.
For example, if you don't do group by,
No, group by you should do. You should do.
no, I'll show you one second. Going in, you can see that for each Kepler ID, there will be, for example, for this Kepler ID, there are 3 planets. Okay, so either you can count the coin name or you can count planet table itself. Because if you do planet dot star, you'll get all the columns.
Okay.
Got it?
Yeah.
So either you can count planet itself, or you can count one of the column of planet which is unique. Group column.
Do one thing, right? Having count of coin name greater than one or something, so that you output the systems for which there are it's multiplanetary systems.
Yeah,
Yeah, this makes sense. So basically, each of these entries is a separate solar system with the number of planets.
correct. So each of this solar system has 4 exoplanets. So 4 planets actually. We can even do something where and we can make sure the exoplanets are confirmed and not just uh, unconfirmed unconfirmed exoplanet. We can do planet dot status equal to confirmed. Yeah, then you can see that it has decreased. Some of them count as decreased. So these are all the uh, solar systems which have confirmed exoplanets. This one has 2 confirmed exoplanets. This one has 4 confirmed exoplanets. Do you want to delve deep or what? Sikara?
Yeah, I think Jishnu is here. So we are basically, we're just done with the basics of SQL and kind of an example for querying exoplanets. So Jishnu, if you want to share your screen perhaps and just show us an example, it would be good. Or also talk about the basic use of SQL as well.
Oh, hi. Sorry, I joined from my phone actually. I thought you guys were,
Okay.
I mean, getting along well. Sorry.
I can share the screen.
Yeah, you can just talk about it.
What did you want to show? Which
Simbad,
So
I
you
think.
can go to Simbad.
Sorry?
I'll send you a link, Jivan.
I have sent the link to Sitara.
Yeah, send.
So it's not SQL per se, but this is something you could do. So Simbad is really a catalog of all the objects that are cataloged basically. So it contains. So for those of you who don't know, any kind of astronomical object you can find in Simbad. So this allows you to do basic queries within the website itself. Also, you could do a script query. So this you could do by going to script query here. So Jeevan, script query. You can do SQL like queries here, or you could do basic queries. And this you can do it from your command line. As in, okay, you can try an example that they've given there. If you go to the just query ID and type in Algol something, or Andromeda.
Algol, LL.
Oh, okay. Star name. They need exact star name probably. So Beta Lyrae, something like that. Okay, can you look at the help there? Help. Top right. Next to output. No. Okay, go back just for a second. Go back. Yeah. Do you see Simbad script execution title on top?
Yep.
Yeah, next to that.
Okay. Let's do this one.
I'll just quickly find out. So I have a set of scripts which I have written long time and haven't even.
Yeah, we got some output.
Yeah. Okay. So yeah, okay. This is, so they're giving you details of all the stars that they have identified from the HD1 catalog, I think.
Right.
Object type, SP. Oh, this is a galaxy. I don't know what it is. Oh yeah, this is a galaxy, I think. HD1.
Okay.
And they'll give you all the references, etc. So this is one of the places where you can find a lot of data. So you can do a basic query as well. Just type in HD1 there, and it should give you what it actually looks like. Yeah. Oh, this is a binary star, HD1. So from here you can find a lot of details uh, about the star itself and a lot of references to any object that you want to query. So in basic query, you can submit queries like pulsars or I don't know, specific names of things that you could try out. Like you can just try out Vega or Sirius stars that you know.
What is the identifier?
Vega, just type in Vega, it should give you.
Okay.
Yeah. So the actual star's name is Alpha Lyrae. So it's in constellation of.
Can we find black holes also? Black
Yeah,
holes too.
you can find black holes.
Sagittarius A star. We can try that.
Sagittarius A. You can try out Sagittarius A. Okay, so it has given you a list of things. Yeah, SGRA. O type is what gives you what the type of the object is. Yeah, I think that's it. Yeah, this is your black hole, probably. Surely looks black.
How could we come to know that what celestial body it is exact? Where is it mentioned?
Okay, just a second. I'll query it myself. SGRA.
You got back on your computer?
Yeah, but I can't access Zoom, so
Okay.
I will.
So
I'll
what is given here?
I'll send the link to Sitara. Is that fine?
Yeah.
Send it to her. Yeah, it's the same thing. So this is an X-ray source, so that is one way you would know that this is a black hole. But I think they have very little, data on this particular thing. So if you come down, there are references and there are identifiers. So this particular object would be it would show up in different catalogs. Like if you come down, there are lots of links where people have external archives. Just above that there are references. You can display the references and it will show you a lot of references where they have studied this object. Display right there to your left side. Okay, scroll down. So these are all science papers which people have published and Simbad have cataloged. Not everything would be relevant, but yeah. And the other way, if you want to like get an exclusive catalog of black holes only, Jeevan, on the top panel there is something called Vizier. Can you see top nav bar? Yeah. So here you can just type black hole or black hole. Find, that should. So these are all catalogs of black holes. From here you would have to, okay, so there are AGN catalogs. Yeah, on the left side. Okay, just click on it, anything, central black hole in okay. Or above that there is near IR spectroscopy of some black holes. Yeah. So these are all the data that is available to you from this particular catalog. Now you can download this as CSV, TSV, HTML, anything. And to do that, given on the left panel, there is preferences. Right, there. You can download that as any format that you want. For now, you can just click HTML table and display. And max will tell you how much of the data you want.
I had a doubt. Can I?
Yeah, sure.
Like there is something called as JMag and IMag. So is it magnitude? And
so
what kind of magnitude measuring in a black hole?
So JMag and IMag are J and I are infrared bands. So people would have actually looked at accretion disks or something like that. So you go here and click on anything. There are definitions given there. Yeah, J band magnitude. So everything has little tooltips that will tell you what's happening. IJK are infrared bands basically.
Okay, thank you.
Yeah. So these queries you could do through this website, and you could do it through like command line or programming. So there is an interface called Astro Query. I think for you guys at least, this would be the best way to get started with finding out data that's relevant to you. If you're using Astro Query, you can do things like whole catalog queries, or you can download data. So it is similar to the SQL that you have been doing, but then there are little APIs that we have to learn.
Excuse me, hello.
Yeah.
Can you access this data in from Python also, Jupyter Notebook?
Yes. So that is what Astro Query does for you. So you can just take a look at the package of Astro Query. It is an AstroPy affiliated package.
Okay.
And using this, you can query a lot of stuff. Whatever we have been doing so far, you can do the same thing. Right. Yeah, here it is. So that will allow you to get the data into your NumPy arrays or pandas data frames. So you can abstract out SQL and use it.
Yeah, thank you.
Okay. You might have to install it, I think, Jeevan. Yeah. Oh, you already have it. Right. Right.
Yeah.
Okay. Instead of pprint, if you do just print, you will get a longer list, I think. Oh, you might have to do theta c print and that variable name. Like in the next cell, you can type print and inside the yeah, okay, that also works.
No, it only has so much data.
Oh. And why is there dot in the middle? I don't know.
Not sure.
So you can do Vega there, Simba query object Vega. It will give you whatever we just looked at. Right. So it will give you coordinates. Just type, just print theta LC. Okay, without print, just that. Okay, yeah, that's a table. So this gives you array deck, magnitudes, etc. I think. Oh yeah, there are lots of stuff.
Is it like this? How to access something?
Probably that, yeah. So what is the type of this thing? It's a table, I think, AstroPy table.
Yeah, it's their own data type. Yeah, AstroPy table.
Yeah, okay. So this is similar to a data frame, but then structurally it's somewhat different, I think. But yeah, I think you get the idea.
Okay.
Then like as far as people who want stuff like photometric data or spectroscopic data, you can even look at MAST archive. So that is another website where you can find a lot of data.
Anything SDSS?
SDSS, yeah, SDSS is also a good option. So they even have an SQL. Yeah, okay, you have reached there.
Yeah. So this is actual SQL itself. So
Right. Yeah, this is actual SQL.
maybe you can understand now. Like it's just selecting top 10, like only the 10 column, 10 rows from this table, and with certain conditions. And these are the columns. And they're using two different tables. One is photo object and spec object, and they're combining them, joining them. Yep.
Is there any private server of SQL like how we have Python 3 to learn and to install? For SQL, is there something like that?
Sorry, I didn't get the question.
I think he meant, is there any way you can install SQL and try stuff?
You can install MySQL, that is the open source SQL
Yeah,
dictionary.
MySQL, even SQLite.
SQLite is better option. It will be very lightweight.
Lightweight. Yeah.
Yeah. Once you install SQLite, you can run queries from your command line, or you can even use Jupyter Lab. Jupyter Lab has SQL extension. Or you can use MySQL Workbench, or you can even use Python directly with SQL.
So basically,
Okay, thank you.
y- so basically, you need SQL for observational data, right?
You don't need it per se, it makes your life easier.
Yeah, but it is usually more required for people who are from the observational field, right?
Not necessary, as in whatever, if you're working with data in a large quantity, then it's necessary. Even if you don't know, like NASA IDS itself is a huge database. So they're doing SQL in the background, we don't know that, but it's there. So it's like that. If you so to answer your question, yeah, if you need data, you would probably have to learn SQL or some way of getting around it, like learning Python wrappers, which will do the job for you.
Okay.
Anything else, Siddharth?
I just wanted to ask something.
Okay.
There are like quite a lot of programming languages.
Uh-huh.
Would you advise an undergraduate to learn at least one of the most important programming languages that are being used right now?
So I think at least in astronomy, Python is the go-to language because a lot of libraries are written in Python, be it AstroPy or SciPy, NumPy. A lot of things that people use are all Python based. There is even a little push for Julia. Julia is really good, but then as far as like mainstream astronomy or a lot of things relating to optical or gravitational waves or extra astronomy, these are written in Python. So good way to start would be learn Python. Obviously my opinion would be biased because it's the only language that I know very well. So you could ask other people as well to get get their opinions.
Yeah. I think the in scientific community there is Fortran, Python, Julia, and R maybe for machine learning.
Yeah, R is mainly towards statistical people.
Correct. But if you want easy syntax, powerful, good community,
Yeah,
great,
true.
then
True.
Python. Yeah. So yeah, Python is a language you should learn, even if you don't.
And yeah, people even use things like ideal or GDL if you're from Linux world, MATLAB. But whatever those languages can do, Python can do as well. Though there are certain limitations, but the advantage that you have when you're learning Python or any general purpose language like Python is you can do a lot more things with it than just do your research work. And if you're starting to learn something, it's best that you would learn with some project, as in begin something or have an objective or have a task that you want to do with this particular language and then go ahead and do that. I think that would be a good path. What do you think, Jeevan?
Yeah, same. I also learned programming the same way. Like think of an objective, otherwise you won't know why you're learning. If you have a clear objective, the motivation will also be stronger. You won't get bored, or you will have a clear vision on why you're learning it. If you have some project in your mind. Yeah.
Yeah, true. So I can, like, you are in your undergraduates right now, right? I learned programming in the second year of my master's. So you are not far behind, and you have a lot of time to learn the stuff.
Yeah, it's programming is the most natural language for scientists. I heard it shouldn't take much time to learn.
True, like if you have something to do and some problem to solve, that's the natural step, I think. Or if you're just plain lazy, you can offload your tasks, repetitive tasks to the computer and learn that way.
Correct.
As in, a good example would be managing Excel sheets or like maintaining your own file structure. These are things you will most likely waste time on. So why not learn some scripting, some programming, and these tasks can be automated.
You earlier mentioned about projects. So, should we do like projects under some supervisor or?
No. I meant like simple projects that you could do online or your own projects. As in, okay, so I'll tell you how I started. So I
Like
had
mini
joined.
projects.
Yeah, mini projects. Mini projects are a good way. So during my MSc second year, I had to do a project work and I had to collect a lot of data and process that data. And I did not know how to do that. So initially, what I thought was, you could go on this website, copy paste all the data, then make tables like that. But then soon it became very, very tedious because the amount of data was huge. So eventually, I had to figure out a way to, control or get a grasp of this whole thing. And that is how I started programming basically, like at a very, very basic level. But you guys have so much of exposure now. You have known so many things. You all have, I think, somewhat basics of Python, right? So you can get started with simple projects like, I don't know. I think Jeevan can give better suggestions on project topics.
Eh, You can start by simulation, I think.
Oh yeah. Simulation of simulation of objects, or like simple pendulum.
Simple
Put in
pen.
all the equations, make lines of Laplace transform, things like that.
Correct.
So I mean, where should we get the reference for all of this?
So Google Baba.
Okay.
And Stack Overflow. But then I think I can, whatever you want to try in programming, people would have already done it. And whatever problems that you're going to face, people would have already faced those problems. So we are lucky in many ways because the year is 2020 and the like capacity for human errors is so huge that any possible kind of error has already been done by people. So don't have to worry about that part. Or you could just ask people, you can ask us, no issues.
Yeah.
Okay. Thank you.
Okay.
But just because it's all.
Excuse me, I have a question,
Yeah, go ahead.
which is not exactly related to topic. The thing was confusing between OS, operating system. Like we have Windows, then also we use Linux, and the people for hacking people, ethical hacking people use Kali Linux. Why is it exactly? I mean, why we need exactly Linux? Compared to
I,
Windows.
I could, Jeevan, could you hear his question?
No, I couldn't hear. I think if
Okay.
I heard little bit. I think he asked why do you need Linux instead of Windows? Is
Oh
that right?
yeah. I think that's the
Is
gist
it
of it.
audible now?
Yeah,
Hello.
it is quite audible now.
Yeah, I asked that why we exactly need Linux rather than Windows. Like people in ethical hacking use Kali Linux, right?
Okay.
Why is it exactly a Linux? Why not Windows? We can't do there.
Okay. So I will probably give you like a broad picture. So Linux is used by not just hackers. If you go to like any serious scientific community, people would be using either Mac or Linux. You will find very, very less number of people using Windows. So there are two kinds of operating systems. One is Unix based systems, and under Unix based comes Mac, Linux, etc. Then you have your Windows based system. Now, if you have noticed that Windows usually have viruses, or rather antiviruses, such problems. and that's primarily due to Windows basically uses a kernel called NT-kernel. It's not very secure, and it is easy for you to get higher privileges. As in, if you want to execute something as the administrator, or if you want to wipe out your entire hard disk, do some unintentional things, it's quite easy to do that in Windows. Whereas in Linux, you have granular security control. So if you want to wipe your entire hard disk, you should know the password at each point. And it's not easy for programs to execute directly within the system itself. And in Unix systems, everything is a file. Whereas in Windows, you don't know what is actually going on under the hood. So if you want to get the best performance out of your computer, Linux or Mac OS is the best bet that you can do. And as for Windows, it is good in some circumstances. For example, graphic designers, video editing, or even for gamers, because there are no other alternatives. But apart from these particular aspects, I think for everyday use and for learning new things, Linux is the best option. And if you ask why specifically Kali Linux, so inside Linux, you have different kinds of versions or flavors, as in you have Windows 8, Windows 10, Windows 7. Similarly, in Linux, you have different distributions like Ubuntu or Linux Mint or Kali or Parrot OS, etc. Each of these have the same underlying system, but then the way things are managed are different. So if you look at Kali, you will have a lot more extra packages related to hacking or pen testing, etc. As in comparison with Ubuntu, you will have more like general purpose things. You will have a office software. You will have web browser, or general things that you would that any normal person would require. Whereas the other thing is very specialized. Did I answer your question?
Yeah, exactly.
Okay.
Thank you so much.
Then I wanted to add on to the same. Why do people use Windows?
Because it's convenient. I don't know.
Not just that, also because it's commercial.
Oh yeah.
They have so much money that they can enforce Windows in all the schools, universities, and all the computers you buy from market. They make it pre-installed Windows because
Right.
the vendors the money. So there is commercial reason also. Yeah.
And it is good, like if you think of it in that sense, it is good that a lot of people use Windows, because wherever there are more users, there will be more viruses and more security issues there. So as from a Linux user standpoint, it is good that lots of people use Windows.
Yeah. And Linux is open source, which means
Right.
every line of code is checked by so many developers. So bugs are like very rare in Linux because so many developers are looking into it, and the source code is free to look at. Windows is very closed, and only Windows developers are have access to the code, so you don't really know what is happening. There could be a lot of bugs and security issues. Yeah, that is one reason. And the command line, Windows command line is not that powerful. The
Oh
command
yeah.
you can barely do anything. In Linux systems you can do so many things with the command line. You don't really need to open the GUI at all. You can do everything with the command line in Linux. Yeah. Is Sitara here?
I guess not.
Okay, if nothing, no other question, we can end.
So I wanted to ask Jishnu.
Yeah.
Did you do like an undergraduate degree in physics?
Oh yeah, I did physics, electronics, and math.
What about your masters?
I did my master's in astronomy.
Okay, did you do it from India itself?
Yeah, I did it from Osmani University in Hyderabad. I passed out in 2017.
Okay, nice. So, what was your thesis about?
Galaxy cluster, like morphology of galaxies inside cluster environments.
Okay, nice.
So there are lots of morphology is basically whether it's spiral, elliptical, or lenticular. There are different factors that affect their morphology at different redshifts, at different densities. So I studied about that.
Yeah, Jishnu, I have a question. Like someone asked me that.
Okay.
Hello.